Okay, so in this video we're continuing the orech revii, and we brought down here an interesting wheel. It's the Rambam's approximation. The Rambam makes a very nice, he puts down all the mazalas, and he tells you in each of them how much you should add or subtract the orech hashlishi to find the orech revii. And he goes, let's start from Teleh, 1/6. So let's say you have 15 degrees, you make 15 times 1.1666. That's a 6 of 15 is like 2 and something degree. You add that. That's going to be the orech revii. If you're dealing in shor, means that the sun and the moon are in shor. So then we add a fifth, even more. To again a sixth. Sartan, nothing, no change. Aryeh, you deduct a fifth. So let's assume that the sun and the moon are both in Aryeh, and there is 15 degrees. The orech hashlishi is 15 degrees. So the orech revii would be a fifth of 15 is 3. So it will be 12 degrees. So you deduct a fifth. Basula, it's a huge jump, a third. So in the same story, let's say the sun and the moon are both in Basula. What we do is and let's say again the same example, they're 15 degrees apart, so the orech hashlishi is 15. Again, we understand from previous shiurim, doesn't mean the moon is literally 15 degrees. It just means the orech hashlishi, but that's a certain imaginary point. Ki'ilu, the moon is in a certain point of the ecliptic. We explained it already hundreds of times. It means we find a point on the ecliptic that has the same right ascension like where the moon really is. But anyway, we have some kind of point, some imaginary point. We call that orech hashlishi. And if there is 15 degrees, they're both in Basula and 15 degrees apart, so we say, let's deduct a third, so that's 5 degrees. So from 15, we turn into 10. That's the huge deduction we make, because that's when we can see, we'll see in the chart soon, that's when in that area, the ecliptic sets very fast. So even though it's many degrees on the ecliptic, it's very few degrees on the right ascension. Now look at interesting thing. The Rambam, it's very nice to see this wheel, because the Rambam, everything here has like you see, Teleh and Dogim, Shor and Deli, Gideon to Kashas and Sartan, Arya and Akriv, Basula and Boznaim. Each one has a partner. So this is a nice way how to understand it. So we really only have to give a chart for this area from Teleh till Basula, and then the other ones can be deduced simply by taking 360 minus that. For example, Shor is 30 to 60. The same thing applies by Deli. That's 360 minus 360 minus 30. That's 330. And 360 minus 60 is 300. So each one has a how do you say, a complement. It's degrees from 0 to 180, and then each one also has a 360 minus that. Okay, so that's why soon I'll show you I only made from 0 to 180, because the rest you can just figure out on your own by taking, if you have anything that goes from 180 to 360, you make 360 minus that number, and then you can find it in the original chart from here, from Talet till the end of the surah. Let's continue. Let's scroll down a little bit here. Okay, so this is a very nice chart. This is my first chart. This shows you, it starts off from 0. Now the x-axis shows the right ascension, and the y-axis shows the ecliptic. So let's just, it's very, very clear. I zoomed in so you should be able to see each part very clear how it works. Let's take 2 points and let's see how beautiful this works out. So we'll take it from, for example, let's assume you want to know how many minutes it takes from 10 degrees. You see, this is the ecliptic. If you take 10 till 20, 20 is here. So this point we're pointing right now, you can see from it's by the right ascension, it's 10, 11, it's almost 12. Let's say it's 11.7. If you take it down, you write down on the paper 11.7. That's the first point where you see here's 11.7. I can't be exact. Let's assume it's 11.7. Then go up to 20, all the way here. And you see this point here is 23.5. So you take 23.5 minus 11.7. This you can do by hand or by calculator. So you do it, 15 minus 7 is 8, 22, so it's 11.8. What does this mean? It means that the orech hashlishi is 10. The orech revii is 11.8. And you see how close it is? Because 10 times 1.6 would be 11.6, and this is 11.8. So it's very close to the approximation of the Rambam. This is the way we can see how these two things have a certain relationship that you can see at each time in Eretz Yisrael. Obviously, this is for Eretz Yisrael. This point, the x-axis tells you what point of the celestial equator is on the horizon. The y-axis tells you what point of the ecliptic is on the horizon. That's throughout the whole movement of the celestial equator. We can see at each given moment what point of the ecliptic is there, and we can see that in this area the ecliptic moves slowly compared to the celestial equator, because the celestial equator moved 11.8 and this only moved 10. So this is what we're talking about, that by the time of the Taleh we have to add we have to make times 1.166, because it takes the mazalas. Mazalas are going slow, so that's why we need to add this extra 11. As I said, 11.8. That's how long it takes. 11. And if you want to know how many minutes, just make 11.8 times 4. That's how many minutes. Because each degree of the celestial equator takes 4 minutes. So it's about 46 minutes. Okay, let's scroll down a little bit here to see the next chart. The next chart shows the next part, that's from 30 to 60. What we see here is again, we see the x-axis and the y-axis. I'm just going to show you here how it's even stronger. Let's see here. Oh, good. Okay, I want to show you here that we said that in the shoyer area, you have to add a fifth. Rambam says. So this is like an extreme. That's how slow the ecliptic sets compared to the celestial equator. And let's take again. Let's make we'll take now 35 to 45. So let's take we'll see by 35 we read the x-axis, and you can see here in the chart it's 41.2 41.2, I would say. That's how it looks for me. 41.2. So you write it down on the paper, 41.2. That's where the celestial equator is when 35 is on the horizon. 41.2. Okay. Now you go to 45 here. You see this point here is it's a drop after 48. Let's make 48 point. Let's say it's also 48.2. No, I'm sorry. I'm outside. It's 50. Again, this is 55. So it's 50. I made a mistake. It's 50. 53.2. 53.2. So again, we have here, we're jumping from, the ecliptic is setting from 35 to 45. By 35, we write down 41.2 and 53.2. So there is a difference here of exactly 12. Now guess what? Amazing. It's exactly the Rambam's prediction, because you take 10 degrees of the ecliptic, 10 times 1 and a fifth is exactly 12. 10 times 1.2 is 12. So we see how accurate it is. This goes together with the Rambam that by Shoyer, it's the biggest difference, and you add a fifth to the orech shlishi to find orech revii. Okay, here, this is just, we're going through here pieces of pieces. Again, remember always that this represents the celestial equator, and this represents the ecliptic. I made for all the, all the sections to be very clear, and I'll just go to show the extreme case in the area of Maiznaim to show you the opposite. I'm not going to go through each section, so I'll just go here, this area here. Let's again take the same thing. We'll want to know 165 to 175. 165 of the ecliptic. So we see when 165 of the ecliptic is on the horizon, we have also 160. Wow, it's so spread out here, so you can see it's very clear here. You see this axis here, we have 1, 2, 3, 4, 5, but the x-axis goes by 168. It goes by 168. 168 is divided into 5 pieces. So it's very, very accurate here. So let's take a look. We'll start 165. And this point here, I would say, is, let's see, 2 divided by 5 pieces. So each one would be 2/5. So this is 4/5, 6/5, 8/5. Each one is 2/5. And this is probably less than a fifth even. Maybe it's a sixth or seventh. I don't know. For me, I would say it's maybe an eighth. So it's an eighth. So it would be 169 and 7/8. That's how accurate it is. 100. So you write down 169 and 7/8. That point is from the right ascension. That's when we have 165. Okay, now let's go up here to 175, and again we have a very accurate from the x-axis is very accurate. So we said each one is 2/5. So it's 176 and 4/5. I would say 2/5. It would be 4/5 would be 3/5. A little bit more than 3/5 maybe. let's make it 3/5. Okay, can't go okay, so detailed. So we'll say it's 176 and 3/5. Now we deduct these 176 and 3/5, 169. So we have here 6 and 3/5, a little bit more than 6. Let's say 6 and 4/5 degrees. Wow. So look what happened here. We moved 10 degrees, but we made a huge deduction. We made this deduction of a third. The Rambam says a third. How much is a third from 10? 3 and a third. That's what deduction we made here, because we only are left over with 6 and even less than 4/5. So it's 6 and 2/3. It's very, very accurate. If you figure out it will mamish like extremely accurate. So this is the time when the ecliptic sets fast in relationship to the celestial equator, because we had 10 degrees of the ecliptic setting, and that only took us 6 and 2/3 degree. That is 6 and 2/3 times 4 is about 27 minutes. Wow, that's much less than it should have taken, the 40 minutes. So this is the time when the ecliptic sets very fast. I hope you enjoyed this. This is very, very clear. These graphs, as I showed you, it goes through each. If you want to order my sefer, you can send me email to weekly Gilyon, WEEKLY GILYON. I can send you all these graphs, and you see this thing also, and then you can see this is the very general graph, and this is the formula I use to make the graphs. You can see it here. It's the cotangent formula, I call it. I put it down here. This is the formula that I used, and then for the second graph I added uh, at 180 plus. I just brought down this graph, but really you can always add 180, and then you get the second graph. I didn't okay, I didn't show you how to do this, but this is all the graphs. I hope you enjoyed this. Thank you very much.